So tangent and normal is considered as one of the application of derivatives. So when we talk about application of derivatives or differentiation, it means that what can we do with differentiation of a function. So we know that this dy by dx signifies gradient. Geometrically, this is a gradient of a tangent for a function at a point. This is too complicated, so let me just show you on the graph. So let's say if this is a function, and if I take any point on this curve, and if I draw a tangent over here, then the gradient of this tangent, which can be written as tan theta, or we have other formulas also, this is equal to dy by dx. So that is like an application of differentiation for function. Now, how do we use this application to get tangent and normal? So firstly, you should be clear that when we say a tangent and normal, we are just talking about tangent and normals as two lines for whom we have to find anything what they ask. Now, whenever we have to find anything for a line, there can be maximum two things, either the gradient or intercept, or any connected thing which can be obtained using y is equal to mx plus c, or y minus y1 is equal to mx minus x1. These are the two equations which will be used for solving questions on tangent normal. Now, when we find dy by dx, so dy by dx means we are actually finding gradient of a tangent. But when we talk about normal, so normal is a line which is perpendicular to the tangent. So if I have, let's say this is m1 as gradient of a tangent. So for normal, I will consider m2, and m2 will be equal to negative reciprocal of gradient of tangent because the lines are perpendicular. So primarily, that is the only thing we should know about this topic as of now. And then when we will solve more and more questions, it will become more clear. So this is all about tangent and normal. I'm not discussing how to find equation of a line because it is assumed that at this level, we guys are aware how to deal with equation of line, but more we will see in a question.